Hello, welcome back to Hot Wrench Fabrication Shop. A little update on the Tatum TRX 18 that I'm building. It's been a couple months since I've did the last video because it's been a couple months I've been trying to get an engine for this thing. It's crazy, but it's come along pretty good. Got a little bit more done onto it. Let me show you guys what's up. That's not what's up. Technical difficulty. There we go. Alright, so front end's all done now. Those aren't the tires that are going on it. Those are actually off of my car. But as you can see, front end's all done. Actually, it's a rolling chassis now. Got most of the wiring done. So that's our wiring panel there. Got the Switch Pros module in there. Switch Pros is a digital switching system. It's pretty cool. It's just all push button. So little panel that I made for it. So that'll be all hidden under the dash, obviously. Wires are all strung throughout the whole entire chassis. They're all popping out everywhere that we need it. You know, whips back there and lights back there, and got the brake lines on. See the brake lines running along there. So yeah, I got kind of a mess everywhere, but it's definitely come along. So I started with the engines back in February. Actually, I ordered one from the machine shop. Top motor is a LS2 aluminum that came out of this car. It's already bored 30 over and we can't go anymore. Technically we can go 40 over, but not with turbos. Too much boost, not real safe. They could sleeve this motor, but very expensive and nobody wants to do it. Plus it's aluminum, so they say not a great idea. So we were going to go with a steel block, and in the meantime I found another block, that one down below. I'm like, sweet, picked that up, got it home, took it to the machine shop, and turned out that it was cracked on the cylinder, so I got ripped off. Wonderful. So now I have a 6-liter steel block that I was gonna go with after the aluminum block was junk. And then we got the second aluminum block, started working on that, and then turned out to be junk, so we went back to this, had to order custom pistons, so we ended up with a steel block, 6-liter, so with LQ4 I think is the RPO code on that. Bored out, got the bearings installed, or the cam bearings installed already, so it's good to go. And then I ordered the 408 kit a long time ago for it, but finally got the 408 kit in, which is all this stuff. So I'm going to unbox this and show you what's involved in building a 408 and kind of get into some detail about what it actually takes and what it means to have a 408 stroker and how that comes out of a 6-liter LS series type engine. So that's going to be next. Okay, so here we have 408 stroker kit. So what does that even mean? Stroker kit. So for you that don't know that, stroker kit is a longer stroke on the crankshaft. So the crankshaft stroke is from the center line of the rod journal to basically the center line of the main journal. So it goes all the way up and all the way down. That's the stroke. So stock crank over here has a 3.62 stroke, right? And a stroker crank has a 4-inch stroke. Now, the biggest problem is trying to fit a 4-inch stroke in the deck height. The deck height is how much room you have in your cylinder from the very center of the crankshaft all the way to the top edge of the cylinder. That's called the deck height. I didn't look it up, but I think it's about 9.5 inches. So if I'm putting a longer stroke crank in the same amount of deck height, something has to change. Now they kept the same length rods. So these are Eagle H-beam rods, which are totally BA. These are I-beam rods. These are also Eagles, but they're I-beam rods, so they're closer to the stock rod. And actually the stock rods are pretty decent, but this motor was a twin turbo LS2 with about 750 horsepower, so we had to get something a little bit better. So this is what was in there before. Turbo pistons, you see the little dish on there. And this is what we're going with now. So the rods are actually the same length. Now what they used to do was put a shorter rod in there with the same piston, and that would compensate for the longer throw on the crankshaft. But now what they're doing is they're making the piston shorter, so it keeps the piston speed the same. So with a shorter rod, it would increase the piston speed significantly, and that would cause a little bit more wear. So, as you can see here, that's the difference right there. Whoop. Well, hold on now. I need a camera assistant. See the difference? So, the old one, a little bit taller than that. So, they just basically shrunk this piston down. So the bottom edges are about the same, but the overall piston is shorter, and that compensates for the room and makes it all fit. Now, one of the problems with running a stroked motor is that it pulls it down further because the obviously the stroke's longer. Getting all confused here. Stroke's longer, so it's going to pull it down in the motor further. So you need to make sure that you have enough clearance. All right, so I'm going to pre-assemble this engine, kind of put it all together, and just make sure that we have enough clearance down below at the bottom. So with a little bit bigger journals flipping around, sometimes these edges down here have to be clearanced just a little bit. Now I was told that these motors are pretty much set up for this, so hopefully I won't have to do much clearancing, but we'll see. Alright, so I'm going to pre-assemble this engine, kind of put it all together, and just make sure that we have enough clearance down below at the bottom. So with a little bit bigger journals flipping around, sometimes these edges down here have to be clearanced just a little bit. Now I was told that these motors are pretty much set up for this, so hopefully I won't have to do much clearancing, but we'll see. Okay, so let's go over some numbers and see how all this stuff works out. So we have a 6-liter engine, and we want to convert that to cubic inch just to see where we're at. So we multiply that times 60.6. So 363.6, they call it a 364 cubic inch motor. So LS1 5.7 liter is 350 cubic inch. This one's just slightly bigger at 363. So how do we convert this and what's going on with the stroker motor? So to get the size of the engine, you go bore times stroke. So we had a 362 stroke engine times 0.7854. That's 45.49 cubic inches per cylinder times 8 equals 363.9, so we get 364 cubic inches. All right, so bored out to 4.030 times 4.030 times our new stroke of 4 inches times our 7.54, 0.7854 equals 51.02 times 8, bada bing, bada boom, 408. So that's how we get a 408 stroker motor. Easy peasy, cover girl. Boop. So math is cool. Math works. So we're basically taking same bore, 4-inch stroke, and we get 408 cubic inches instead of 364. Significantly different. Put a couple of turbos on there. Bada boom, bada bing. We're talking 800 or 1,000 horsepower. Shooting for 1,000, but it is what it is. Anything over the 750 that we had before is going to be a lot. I'm getting some messages. Holy cow. Somebody wants to get a hold of me. So yeah, it's going to be cool. So I'll pre-assemble this thing. Actually, next I'm going to talk about the balancing part. I was going to mention the old school stroker motors. The easiest one was a 350 Chevy that they would put a 400 small block crank in it and get a 383. So most of you guys have heard of 383. It's a very common stroker motor for the old 350s. So kind of the same thing. We're just putting different crankshaft in there. So let's talk about balancing. You've heard of balance and blueprint in motors. Well, they all have to be balanced so that they don't vibrate. And trust me, I learned my lesson on that, and I'll go over that in a minute. So basically what they do is they take each piston and they weigh it. There's the piston. Weigh it on a gram scale, match those 100%. Get them all exactly the same weight. Then they take the rods and they put the small end, they hang the big end on a little hanger. They put the small end on the scale and they measure the small end and they match all those up. So on this one, I don't know if you could tell, but this one's been ground down. So they grind all of those, they match them all up. I think one of these, yeah, this one was not ground, so this is the lightest one. So they measure the lightest one, they ground all the other ones to make a match. This one wasn't ground either, so those must have matched already. That one matched. This one was ground. So the manufacturing process nowadays, they really don't need to be ground much because they're so close already. And then, of course, they do the same thing for the bottom end. Measure the bottom end, and then they'll take just a little bit of material off the bottom, and then that matches. And then they weigh the rings, the wrist pins, and all of that, and that becomes what's called bob weight. So here are the measurements. So we have a piston that's 510 grams, rod 440, and then the circlip and rings is 173. That's the total assembly of one cylinder. Multiply that times 2, and you get a bob weight of 1699. So there is 2 of those assemblies that go on each journal, so that's why you double the weight. You take that 1699, and they have a big weight that they are able to clamp onto here. 1699, 1699, 1699, 1699. And then they spin the crank up, and they balance that whole thing. So you can see here, I shaved a little bit off, shaved some off, drilled a hole, drilled another hole over here. So that's how they balance these. Now sometimes they have to actually add weight to it. It's called heavy metal. And they'll put weight in there to balance those out. Now what happens if you don't balance them? Well, if you don't balance them, the vibration, actually the harmonics of that vibration, will absolutely kill the bearings. And that's what I did on mine. So this is the crankshaft somewhere out of my motor. And I killed the main bearings because I didn't balance it. Now why didn't I balance it? Well, most of these motors are actually pre-balanced. It's one of the cool things that Chevy did. The 5.3 6-liter 5.3 5.7 and the 6-liter all the same cranks. So is the 6.2, and they're all the same rods. So they changed the weight of the pistons so that you can run any combination and it would match. Chevy did a phenomenal job with engineering this motor. They're all the same, all covers the same. It's so cool that you can just swap parts. Well, I have a 6.2 liter. And my dumbass, can I say dumbass on here? Left out a plug when I first put this motor together. And the machine shop had cleaned everything out, gave me everything. I was in a rush of putting it together. I left out this plug. And I started it up and it had no oil pressure. I'm like, it's kind of weird. It's all brand new. So ran it for a little bit and it never came back up. Checked the sender, started it again. Actually, I swapped one out because I had one, no oil pressure. Checked some wires, started it up. So I ended up starting it up 4 or 5 times and never had any oil pressure. So that killed the bearings. Imagine that. So I had another crank laying around, that one down there, which was the same part number, same crank. So I'm like, I'll just throw that in there. So I threw that one in there, and as soon as I started it up, I noticed, it's got a little vibration. Not good. Took it to the dunes and killed the bearings. I mean, it was bad. It vibrated like crazy. So the vibration and the harmonics just eats the bearings up. So I was just watching the oil pressure slowly drop down. And I'm like, boy. So I got another crank, and I was in a hurry, threw it together, and did the same thing. Started it up, started vibrating instantly. So I took it all back apart, and now I sent that whole motor, or the rotating assembly, down to the machine shop, and they're balancing everything, and then that one's going to go back together as soon as that comes back. So that's the one that's out of my dune buggy. 6.2 cam, really cool little intake. It's a FI Tech intake. Right over here. So it ran really good until it didn't. That's the 6.2 liter heads. So this motor's pretty neat. It's actually about, I'm guessing 500 horse. That's what most of the people say with the combination I'm running. I haven't had it dynoed yet, but it's plenty for that car. You can tell it's a lot because it really woke it up. But like I was saying, the cool thing about these engines is this is a 6.2 liter. And the cams, the front covers, the main caps, the heads, everything swaps over. All that is identical to this old truck motor. This is an old 6 liter steel truck motor. That's a 6.2 liter 6.2 liter aluminum motor, and everything's the same. So it's really, really cool. Covers in the back are the same, cams are the same. You can mix and match all that stuff. So kudos for Chevy for hooking us up. So yeah, next thing I'm going to do is kind of assemble this thing and see where the clearances are. Okay, so got the pistons installed on the rods. And next, put them in. So you got to be super careful on these. So you can see, maybe, it says a little front on there. So we have the bigger eyebrow. It's for the intake valve. So with that in the front, this would basically be your number 1. And then this chamfer down here, that chamfer, a little bit bigger on that side than it is on that side. So that chamfer goes to the outside of the rod journal. So like that. So that chamfer goes that way, flip it around, the other bigger chamfer goes on that way. This is called a fillet right here. And that fillet is kind of beveled for the bigger chamfer. So I put all these on so the front's going the right way and the chamfer's going the right way. And now I'm going to put the bearings in this thing and lay it in there and see what the clearances look like. Okay, so Bottom end is coming together. Put the crank in there. Put one rod on. And checking the clearance. And you can see right there at the bolt of the rod to the cylinder, there's plenty of clearance. Yeah, at least 1/4 of an inch. So back in the day with the old small block Chevys, you would have to clearance that out, grind a little bit off there, but this motor has plenty of room, so hey, we're good to go. So right now I don't have any rings in it. On this side doesn't have an issue whatsoever. Plenty of room. But so yeah, stroker build is on its way. So now I'll take it back apart. Actually gonna go get the block Cerakoted. It's a special coating that they put on there, high temp. It's almost like anodizing. It's gonna be black, so it's gonna be a little while before I can actually build the motor, but hey, we're finally making progress, and that's what we want to see. All right, so that's my update. Got done what I needed to get done today, which was huge because, like I said, I've been waiting since February for this, so ridiculous. Now it's July, actually August. Yeah, just turned August, so dune season right around the corner, so I got to get this thing together. So next video is putting that motor together. So get it off, get it Cerakoted, get it back, clean it, and put it together. So we'll catch you next time.